Hello, welcome to this lesson on Bronsted Lowry acids and bases. The question of the day, what should a scientist do if their data and findings do not align with what's already considered to be scientific fact? I would say that they need to redo their experiment a few times to make sure that, they're doing the right thing, and then maybe question what we already know. Okay, an example of this is ammonia, NH3. Okay, so ammonia has a pH somewhere between 8 and 9. And that's fine, except the pH of an 8 or 9 would mean that ammonia is a base. But Arrhenius said that bases should give an OH minus or a hydroxide ion when they dissolve in water. And ammonia doesn't do that. Ammonia doesn't even have an oxygen. How could it possibly donate to the solution a hydroxide ion? Well, the dissociation of ammonia looks like this. We have ammonia, NH3, and water, H2O. And when they come in contact with each other, we get the ammonium ion, NH4+, and we get the hydroxide ion. And this hydroxide ion, according to Arrhenius, means that ammonia is a base. That's kind of crazy. Because where does this hydroxide come from? Well, it has to come from the water. It's the only way because it's the only place where the oxygen is. So we have this guy, team, I honestly couldn't tell you, Bronsted Lowry. The Bronsted Lowry theory comes in and kind of expands on the Arrhenius definition of what it means to be an acid or a base. The Arrhenius theory is still true. It is correct, but it doesn't give the entire picture. So Bronsted Lowry theory comes in and just kind of expands and builds on that definition that we already had. So the Bronsted Lowry theory describes bases as any compound that will accept a hydrogen from water when the substance is dissolved. So what happens is, looking at this example, NH3 is ammonia. It is going to take the hydrogen from water, which we're just rewriting it HOH so that we can see it nicely. It becomes NH4, and the leftovers are hydroxide, and that comes from water. So this, according to the Bronsted Lowry theory, makes NH3 a base. Really, the change in the definition is that the base can come from water. It doesn't have to come from the original substance. Arrhenius says it has to come from the original substance. So that would be lithium hydroxide, magnesium hydroxide, calcium hydroxide. Bronsted Lowry theory says you can still get the hydroxide even if you have to get it from water. As long as there is hydroxide, it's a base. So the idea is that it is going to take the hydrogen, is going to accept the hydrogen from water. And now this is where the language gets a little bit crazy because we're talking about an H plus ion, okay? An H plus ion is a hydrogen atom, one proton, one electron, except that electron's gone now. That's what makes it H plus. So H plus is hydrogen without the electron. Hydrogen without an electron is just a proton. So sometimes we would say that a base is a hydrogen acceptor, and other times we would say a base is a proton acceptor. It means the same thing. Acids, on the other hand, donate a hydrogen. So water will snatch up that hydrogen and it will form H3O+, which we know as the acid ion. So here we have hydrochloric acid, which we already know is an Arrhenius acid. Okay, this Arrhenius acid is going to ionize. We have a hydrogen ion and we have the chloride ion. Well, that hydrogen ion will find its way over to water and it will make H3O+. Because the HCl donated the hydrogen or donated the proton, that makes it an acid. Now, what's a little interesting about Bronsted Lowry theory here is that the theory can make water be defined as an acid or a base. We know that acids and bases are different from water because water is neutral. It's neither acid nor base. But by this definition, some of the water, in this case, is going to be basic. Remember, bases accept protons. So HCl is going to give it away. Water is going to accept it. It's almost kind of like, and I haven't taught this yet, but maybe if you are a standard high school chemistry student, you've already learned redox. Redox just means we're keeping track of electrons moving around in a chemical reaction. So think of ionic bonds. If one element is losing electrons, another element would have to gain electrons. Here we're just tracking hydrogens. So if the hydrochloric acid, HCl, is losing hydrogens and water is picking them up, then HCl is an acid and water is a base. Bronsted Lowry theory can get really crazy and really muddled, but I think for the purposes of high school first year level chemistry, this is really as deep as you need to go. If you are looking for information on conjugate acids and bases, at this point that is not provided on this channel, you'll have to find someone else to help you out, at least for now. I may come back to it later. I haven't decided. But that is all that we're going to talk about here, is how the behavior of water can change based on whether it is accepting a hydrogen and becoming H3O+, or if it is donating that hydrogen and becoming a hydroxide ion. Now, the way to help you remember which one is which is a really bad acronym, BAAD. So bases accept either hydrogen ions or protons, however your language is, whichever you choose. I would say most often I do see it as protons, but the hydrogen will work as well. So bases accept and acids donate. You put those two together and you get BAAD with two A's. Yes, it is a BAAD acronym. Bases accept your protons, they accept hydrogens, and acids are going to donate them. Now, if you have to determine if something is an acid or a base, this is my strategy. Number one, the Arrhenius definition is still going to work. So if you can get the Arrhenius definition to work for you, start there. The Bronsted Lowry theory just added on to this definition. So if Arrhenius works, then it's still correct. Secondly, you can look into splitting the chemical reaction into a before and after, and then you find the species that look alike. And then in doing that, you can figure out if a hydrogen was gained or lost, and I'm going to show you what I mean. If we go back to this equation of the hydrochloric acid, the two things that look the most similar are hydrochloric acid and the chloride ion, and then the H2O and H3O. Those are the pairs we're going to look at. So HCl and Cl, the change there in the reactants and the products, the before and after, is that HCl gave away a hydrogen. If it donates a hydrogen, that means that it's an acid, right? Acids donate. HCl is an acid. We already knew that, though, because my first strategy, use the Arrhenius theory first, that worked. Now, water, according to the Arrhenius theory, is neither an acid nor a base, meaning I have to use Bronsted Lowry theory to figure out if it's an acid or a base. Water goes from H2O to H3O, meaning that it accepted a hydrogen. So if water accepts a hydrogen, that makes water a base. In this case, bases accept. So that is how you can figure out whether something is a Bronsted Lowry acid or base. You kind of just look at it as a before and after. All right, that's all I have for you on Bronsted Lowry acids and bases. Please make sure to ask any questions you have in the comment section below the video. Subscribe so you don't miss the next lesson, and I will see you there. Bye.